In this demo, we'll show how to leverage PLAT ONE application enablement feature to develop your application in just few clicks. With PLAT ONE, you can quickly develop and deploy compelling enterprise-grade applications across a range of fixed and mobile devices using the newest HTML5 Internet standard. The starting point to enable this feature is a rich library of HTML5 widgets that are bound to the PLAT ONE data streams. PLAT ONE features a rich set of reusable GUI elements like filterable grids, gauges, charts, editors, and many others. PLAT ONE generates a semantic model associated with all managed M2M resources, and the model is used to automatically build HTML5 panel and forms to represent device status. As we are seeing, if a change is made in the semantic model descriptor of an M2M device, one gets a corresponding change in the graphical representation of the device status. In this case, we change the format attribute associated with the LED color property of a device. Let's now demonstrate how these GUI elements can be assembled together in the PLAT ONE application builder called Snap. Snap allows us to automatically bind the HTML5 GUI widgets against Platform API to create full-functioning web applications in just few clicks. In this example, we are building a simple meter data management system to read data coming from smart gas meters. Let's start selecting the desired layout. After that, I can select a map to represent the location of the gas meters, a grid to represent their data records, and a line chart to draw gas consumption usage statistics. Now let's configure the map. First thing, I'll center the map where I know I have my gas meters. Now I'll bind the map against the PLAT ONE APIs that return the gas meter data. Note that the API I use is a domain-specific API that returns a business object rather than generic sensor data records. What I get is my gas meters on the map. Now I can repeat the binding procedure for the grid. I just select the same API, but this time the return data will be used to populate the grid. The model associated with the data is used to automatically create the grid columns. Finally, we have to bind the chart widget to PLAT ONE in order to represent the historical data on a line chart. The final step is to let the three widgets interact together based on some user-defined logic. For example, let's say we want to select a grids row and populate the line chart when we select the corresponding marker. We can use Snap eventing for that. We can just drag and drop the map's click event over the grid and over the line chart. Then we browse the received event in the grid and we select the desired behavior. Select the row. We now browse the line chart received events and we select the load action for the click event. This just means, please invoke the API I configured before to push data on the chart. That's it. We can just push the play button to bring our application to life. It is possible to download the project just developed and customize it depending on the user needs. In this way, the Snap projects can be seen as live examples on how PLAT ONE behaves, showing how an end user can work with PLAT ONE APIs and graphical user interface elements. Using the Snap approach, we can build many template applications in multiple domains: smart meter data management, fleet management, smart city applications, and many others. In this example, we are showing meter monitor application. We can see a representation of meters on a map, on a filterable grid, and some other extra features. If we select a specific meter, we can browse the properties associated with the asset, like the point of delivery and contract number. We can browse and issue commands that are accepted by the meters. We can access the historical measure generated by the meters. As you note, we are using the very same HTML5 widgets that we saw in action in Snap. The fleet management application is another example on how PLAT ONE can abstract from a set of M2M devices and turn them into powerful business objects ready to be accessed and represented in the user interface application. As we can see, the fleet management application provides also aggregated statistics and data coming from the car rather than from specific sensors and devices installed on the car. The last example is a Mars City application where PLAT ONE is used to model smart lampposts. Also in this use case, device virtualization and clustering provided by PLAT ONE platform allows the end user creating an effective application to browse the records coming from the ballasts rather than from a single device or a set of devices installed on the lampposts.